Hello, and welcome to the release announcement video for AVEVA Pipeline Operations for Liquids 2023. This release accompanies the AVEVA Enterprise SCADA 2023 release and focused on three themes: improving collaboration with and optimizing the control room, extensibility, and lastly, simplified deployment, maintenance, and upgrades. Improving the collaboration with and optimizing the control room was the largest part of the release and added features to improve the functionality of our computational pipeline monitoring leak detection software, Pipeline Monitor, or PLM. The enhancements to PLM were largely focused on detecting anomalies sooner, features to prevent false alarms, and configurable severity by balance or term data. To enable our customers, partners, and project delivery teams to add new features and functionality to the software after release, we continue to focus on adding new extensibility points to the system. With this release, we've added the ability to plug in new volumetric calculations into the system. We also added the ability to convert a level to a volume by specifying a formula in lieu of looking up the volume from a strapping table. Lastly, we've added support for additional density and pressure units of measure that aren't common in North America but are found in other areas of the world like South America. We are also continually looking at ways to take costs out of deploying, upgrading, or maintaining the system. In this release, we've added the station field to a number of the liquids tables so that station alarm rollups occur automatically, which means projects no longer need to do this work. In order to simplify development activities, the developer guide was enhanced to document the APIs associated with retrieving tank strapping metadata and the APIs that can be used to control the automatic mode for DRA at the line and group levels. With the AVEVA Pipeline Operations for Liquids 2023 release, PLM has been enhanced in multiple ways to improve the frequency and accuracy of leak detection. The main change is that the system will now calculate and historize the long-term trends minutely and the extended term trends hourly. Previously, these were being calculated in hourly and daily frequency, respectively. Due to the large increase in the amount of data to store and a limitation for the number of columns that can exist within a table, the previous arrays have been moved into their own tables. The short-term trend data that was stored in the first element of the term data array was moved to a new table called PLM short-term data. The long-term data was moved to PLM long-term data, and the extended term data was moved to PLM extended term data. The linkage to these new tables happens automatically when a PLM record is created. And to help with migrating to this new schema, an upgrade script has been created and is included in the release media. Note that these changes affect the structure of the real-time database only. The historical schema remains the same as in previous releases. PLM has an option to dynamically increase the alarm limits in response to a change on the system that would trigger a transient condition on the system. For example, on a pump start or the opening or closing of a valve, the system can expand the alarm limits to avoid triggering a false alarm. Previously, the software would allow for the definition of a deactivation trigger, which is a signal to let the system know that the transient condition had passed. Or the SCADA administrator could specify the amount of time to hold the expanded alarm limits before decaying back to the normal limits. But there wasn't a way to combine these two. A new option has been added with the 2023 release to allow the user to specify if the system should keep the dynamic alarm limit in effect indefinitely until a deactivation trigger is received, and to then apply a hold time. This is useful in cases where the transient condition hasn't fully passed when the deactivation trigger is fired. The extra hold time enables the SCADA administrator to set tighter alarm limits. To use this feature, the SCADA administrator will toggle the new Hold Persist field on the PLM record by clicking on the checkbox on the Dynamic Alarm Adjustment screen in ADE. Turning this on tells the system to hold the expanded limits until the deactivation trigger is fired. The second step is for the SCADA administrator to specify the amount of time to continue to hold after the deactivation trigger by using the hold time field. Another enhancement to the PLM alarming capabilities is to allow the SCADA administrator to optionally specify the severity of the alarm associated with each of the term trends. For example, the first short-term trend could have a severity of low, while another might be configured for a medium severity. If multiple term trends are in alarm simultaneously, the system will use the highest severity for the alarm. The ability to specify the severity by term trend is accomplished by use of a new message set for PLM that includes 9 additional states. The first 3 states are associated with the short-term trends, the next 3 are for the long-term trends, and the last 3 are for the extended term trends. Alarming on extended term trends is also new with the 2023 release. Note that specifying the severity by trend is optional, and the PLM message set that was used in previous releases can still be utilized. In this case, the system will use the severity associated with the alarm state for all term trends. A number of other enhancements were also made to PLM. Under processing changes, the SCADA administrator can now modify a PLM record's base alarm limits while the record is using the expand limits due to a transient condition. They can now also disable the backfill of data after a communication outage. The default is that backfill is enabled in order to maintain the system behavior across an upgrade. Under alarming enhancements, a return to normal deadband was added to prevent a record from going back and forth between an alarm state and a normal state when the term balance is hovering around the alarm limit. Additionally, an invalid increment configuration was added to each of the input devices to the PLM record. This configuration is meant to be used to filter out bad data from the field. Lastly, if the source record for the PLM vol device is deleted before removing the PLM vol device, the system will generate a new configuration error alarm to alert the SCADA administrator. For customers that require specialized volumetric calculations, we've added the ability to add these calculations using a plugin architecture. The architecture will enable project delivery teams, our partners, or our customers to implement custom logic on how to calculate correction factors and apply them to calculate gross standard volumes for meters, tanks, and line fill. To implement, the developer must create a class that implements the iVolume Correction plugin interface. Once implemented, there's configuration required to extend the correction library enumeration, map the new library to the enumeration, and to tell the system to load the new assembly. The implementation procedure, along with an example, is documented in the developer guide. A new extension point is now available to allow customers to provide their own level-to-volume conversion logic for tanks. With this enhancement, customers are no longer limited to conventional tank strapping lookup tables. They can use a formula-based conversion that takes into account the geometry of the tank and apply any required adjustments. Multiple plugins can be created and added to the system to handle different calculation formulas. Like the volumetric calculation plugins, this is implemented by extending the tank strap enumeration, mapping the plugin to the new enumeration, and having the system load the plugin. For more information, refer to the developer guide. For more details on the enhancements and defects fixed, please see the release notes and the latest user documentation.